Yes. Okay. So recording is
This
started.
meeting is being publicly streamed.
So this is a new topic for you. So we will practice all the questions, inshallah, together for electric. Sorry, the Coulomb forces, electric field, and then this capacitor in this week. So inshallah, today I will try my best to wind up this topic in 1 or 2 days, and then we will be talking about the topic of your yani we will practice these questions, and right after that we will have an assessment because this topic is entirely linked with each other. Electric field, Coulomb forces, and then some capacitor questions or capacitor techniques. So that is why I will prefer to wind up this first and then come to the topic. Okay. So when we talk about capacitors, actually capacitor, this topic is the topic from which you will get one question will be there. You will be asked about one question, and that question is basically asked in different formats, like somehow it is linked with electric fields, somehow it is linked with your alternating current, and it's an independent question as well, capacitor charging and discharging especially. So what a capacitor is an electrical device which stores the energy in the form of charge. Yani that capacitor is an electrical device which stores the energy in the form of charge. It is exactly a water reservoir, dam, I can say. What is the main function of the dam? It stores the energy. It stores the energy in the form of water, isn't it? You got this point? That just like the dams, as they store the energy in the form of water storage, this electrical capacitor store the energy in the form of charges. So why it does not store the charge, or why do we say that it does not store the charge? So here I have given a simplified version of a capacitor. There I will explain this all. Did you see the plates? One black one is basically the it is having positive charges, and that blue the red one is having the electrons mentioned on that. The plate X and plate Y are these two plates. Actually, when you connect the plates to the battery, what happens? The plate which is connected with the negative terminal of the battery, the electrons are accumulated on that plate, and it gets negatively charged. What happens to this plate? This plate gets negatively charged. So it means this has all negative charges. So I will simply say that if total charges are Q, then it is negative Q, right? Because you now that total charge is number of electrons into charge of one electron, that means it is Q. Now there is a problem. The problem is the other plate, the black one, it is neutral till this point. What is that? This plate is still, that was the neutral until you have closed the switch. For example, if I just um, connect the voltage source to this switch, this is a switch. Okay, so that switch means this is a switch. So that switch is now open. Okay, that is an open switch. As you close the switch, what happens? The electrons are moved from negative terminal of the battery to the plate, and now they will start repelling the electrons here in the nearby plate, right? There were electrons definitely, but those electrons are repelled by the red plate because red plate is now negatively charged. So due to that, all the electrons, they goes out of this plate towards the positive of the battery, and this exit of electrons or exile of the electrons, that gives positive charge on these plates. What happens? That gives you a positive charge. Is this clear to everyone? Yes, so this is how that the entire number of electrons which would be pushed out from that, they are n number of electrons. They are the same as the electrons available on the uh, on the plate nearby. So that is why this black plate that would have a positive charge Q. So this positive charge and negative charge together, they are equal in amount. So that is why I can say that amount of positive charge and negative charge is cancelled out. And as a whole, on the plates, yani as a capacitor I'm talking, there is no net charge on this. But on the plates there is a charge. You got this point? Yani one plate is negatively charged and completely negatively charged, and the other plate is completely positively charged. But as a capacitor, if I say negative and positive are equal in amount and opposite in direction, so is there any net charge? No. So that is why we say that no, there is no net charge on the capacitor. That means that capacitor does not charge the that does not store the charge. It stores the energy. And how that energy will be stored? No one asked me that question. That is why I just gave you a chance that whether you will ask me or not. Okay, that entire energy is stored to pull or push these electrons push sorry you know it will be pushed, so to push these electrons away from the black plate, yani plate Y. So the work done to push the electrons out of the plate, it needs an energy, yani it appears in the form of energy, isn't it? Do you agree? Do you people agree with that or
Yes.
not?
Yes, sir. Yes.
I'm saying that these electrons are basically pushed by plate X electrons, right? The electrons of plate Y, they are pushed away, and that means that there is a work done to push the electrons away. So in that case, I can simply say that yes, the work done to push the electrons away from the plate, yani, to create the positive charge on the nearby plate, that work is stored in the form of energy. Is this clear now?
Yes.
Okay. So now there is a construction of a capacitor. There are two conducting parallel plates. Okay, I have shown you those plates, right? Parallel plates. They are connected with a voltage source, and they are separated by an insulating material called dielectric. What is the name of that material? That material is called dielectric. What do we call that material? That material is called your dielectric. Okay, so the work on the that works on the principle of electrostatic. I have mentioned all these points one by one, and I'm going to make you these points clear. That the capacitor works on the principle of electrostatic induction. And energy is stored in the capacitor to push or to repel the electron from the opposite plate, right, or the plate in front of that. And that means that is a work done in the form of electrical potential energy. Because you have studied that electrical potential energy is Q into V. That when you have the potential difference and the charges are created or charges are accumulated, then an energy is basically available or energy is produced there. So that is what the basic concept of capacitor. Now on this slide, I'm going to show you about the material. Actually, dielectric means that the material what you have used inside, that material will be divided into two poles, dipoles. That is electrostatic induction. In electrostatic induction, as I told you, there is one negative plate, that plate X. Plate X was having excessive electrons. That is why the electrons are accumulating on this plate, negative plate, and the nearby insulating material. Actually, this dielectric and insulating material, that material will have uh, electrostatic induction on this one. it will have electrostatic induction. And due to that electrostatic induction, the this size or this side will have positive charge. Why? Because the negative charges will repel the light or light charges away, but this material does not have the tendency to move the electrons out, because that is not a conductor. So that is why the electrons are separated out on one side. So that is the reason that the entire l- left side of this layer one material, that becomes negatively charged, and the layer which is closer to the negative plate, that becomes positively charged. In this way, this negative layer will repel the negative charges of layer 2 of the dielectric. This is layer 2 of dielectric, and these all negatives would be pushed away. During that, there is a positive charge on the nearby ends, and this causes, again, this layer causes the electrons of the black plate Y, to move to the battery. In this way, this works from one plate to another. You got this point? This mechanism is basically used to store the charge, or that mechanism is used to manage the energy of a capacitor on the plates. Is this clear to everyone? Anyway, this principle is called the principle of electrostatic induction, and the charges are accumulated from one, are they're transferred from one plate to another by the concept of electrostatic induction. Is it clear? And dielectric, why do we call this material as a dielectric? Because it is divided into dipoles. It is divided into two poles, which is called dipole. So as a whole, because the material is not that much ionic, there are three states of diagram. Diagram number one, this one. This is a little bit zoomed out, zoomed in, and this is zoomed in at the micro level. So here I shown you at micro level that what happens actually inside the dielectric material or inside the domain. So I hope that this would be clear to you. Yeah, in this blue one here, inside this red plate is your plate X, this black one is your plate Y, and inside that blue material is just like my blue paper or something like that, which is an insulator. So that insulator means that this insulator will be having um, it will have the dipoles inside, and those all dipoles will frame themselves in this way, and in this situation your capacitor gets charged. Actually, I will talk about the capacitance of the capacitor with the dielectric and without dielectric. So I'm moving towards that. So capacitance is basically that property of the capacitor which uh, is an indicator that yes, how much energy can be stored, or it is a measurement that how much energy is stored. You got it? So capacitance of a capacitor is represented by C. First of all, I must tell you that capacitance of a capacitor is represented by C. Its unit is farad, and it is the capacity of a capacitor to store the energy or to hold the charge. Do you get this point? To hold the charge on the plate. So this is the capacitance of capacity of a capacitor to hold the charge. Is it clear? For example, yeah, in exam you will write this definition that the ratio of charge stored at any one of the plate of the capacitor to the potential difference across the plates. There are some important points. The ratio of the charge stored at any one of the plates or any of the plates, because the charge, what if a positive charge is on one plate, the other plate is having the equal amount of negative. So that is why I simply say that the charge stored on any one of the plate divided by the potential difference across the plates. So is this clear to everyone? Okay. So It's C is equal to Q by V. What is the C? That C is basically equals to Q by V. So C is equal to Q by V is the formula you have to recall. That means that Farad, if you are asked to define Farad, Farad is coulomb per volt. What is Farad? Farad is coulomb per volt. And that is, this formula is very common, like your F is equal to MA, your V is equal to IR, your F is equal to V is equal to F lambda. We have this capacitance formula, Q is equal to CV, right? Where Q is the charge stored on any of the plates, V is the potential difference across the plates, and C is the capacitance of the capacitor. Is this clear to everyone? Okay, now if I see the variation between Q and V, so this will be the graph. That graph will tell you about Q and V. That Q and V are directly proportional to each other, and because there is no one intercept, so that is passing through origin. So simply speaking, that Q is C is what? Now here from this point onward, I will be simply talking about the major concept of your graphical analysis. That what is this graph, or what does this graph show you? The gradient of the graph gives you the capacitance. Gradient of the graph gives you capacitance. Is this visible to everyone? The gradient of the graph gives you capacitance of the capacitor. Okay, ji? Any confusion in this one? Because in the graph above, if you see the gradient, what is the gradient of this graph? Isn't it gradient Q divided by V? And isn't it capacitance? Is it not? But
Yes.
then we say that gradient is capacitance. Then we have another calculation. That calculation is basically area of the graph. Area of the graph is energy stored. Will you remember this point? The energy stored. Area of the graph is actually energy stored. You got this point? Is it clear to everyone? What is area of the graph? That is energy stored. So if I take the area is equal to 1 upon 2 Q into V, because it is basically based upon height, isn't it? Do you agree or not? Are you people agree?
Yes.
Okay. So if I want to find out area of this, so area means definitely I have to figure it out that yes, area will be area under this graph. So when it is area under this graph, it is basically 1 upon 2, 1 upon 2 Q times V. 1 upon 2 Q times V. And as I told you that Q is equal to CV, that is why I made both of these as Q as red, and Q is replaced by CV, that is as red. So Q is equal to CV is your graph. So when I say that there are two equations which gives you the energy calculation, so these two equations are what? These two equations are Q is equal to CV, okay, and Q is equal to, oh sorry, yeah, sorry, this one. Q is equal to CV, and what about the other? Sorry. E is equal to 1 by 2 CV, and what else? Which other equation do I have? 1 upon 2 CV square. Okay? And 1 upon 2 QV is one of the equations. Are you getting my point? And what about the other equation? That is 1 by 2 CV square. These are two equations which are required here to understand. Now, here, if I simplify this concept, that energy stored in the capacitor is directly proportional to potential difference square square of potential difference across the capacitor. But the condition is that if the capacitance is same, yani same capacitance means for the same capacitor. This is for same capacitor. Yani if you have a same capacitor, that capacitor will store more energy when it will have more voltages across the plate, and it will store less energy when it has less amount of voltage across it. Is this clear to everyone? Clear? Okay. Then we have that the capacitance of the capacitor is directly proportional to. Then there are the factors. These are the factors which affects are which are here to show you. These are the physical factors actually. So the capacitance of the capacitor is directly proportional to area of the plates, area in front of each other. If there would be more area in front of each other for the capacitors, there will be more capacitance. And if the plates are separated by more distance, the separation between the plates is greater, then capacitance will be decreased. And the third factor, which is basically the nature of the medium, that is relative permittivity. Relative permittivity. So as I told you, the relative permittivity is basically one of the factors which tells us the nature of the medium. So these are three factors. So will you people remember this? What are three factors? Area of the plates. Second, separation between the plates. Third, the nature of material. Got it?
Yeah.
Okay.
Yes.
Now, this is basically, as I told you earlier, the relative permittivity, concept of relative permittivity. What is relative permittivity? Hamzala, can you please tell me? We have discussed that. Epsilon R, the relative permittivity of the medium. ऐसे ही है ना? Now, this relative permittivity is basically the permittivity of the medium with respect to air. So that is why if I say that this relative permittivity is the ratio of permittivity of the medium divided by permittivity of free space. So simply speaking, if you are agree with this, what is this? The permittivity of the medium equals to relative permittivity into permittivity due to free space or permittivity of free space. So simply, I will make two equations here. Yes. Now, this entire slide is very important. In the first half of the slide, I told you that capacitance in the presence of air. Capacitance in the presence of air. When there is air in between the plates, then what will be the capacitance? Capacitance will be epsilon naught A divided by D, isn't it? Is this clear to everyone? Hamzala, Zoya, and yeah, but is it clear to all of you?
Yes, sir.
Okay. So here I can simply say that this is basically the capacitance in the presence of air. But if I apply or if I add any medium, uh, yani instead of air, so I will use that of capacitance in the presence of medium is equal to relative permittivity of the medium into area of the plates, because plates area of the plates is same and separation between the plates is same. So the only thing you have changed is this epsilon of the medium. So epsilon of the medium is equal to what? Epsilon r into epsilon naught. So if I just rearrange this all, epsilon r can be taken out. This epsilon naught A divided by D, isn't it equal to capacitance due to air or capacitance in the presence of air? Is it not? Yes. So that is why, did you notice that if you added that material, the capacitance of the capacitor increases by a factor the relative permittivity of the medium. For example, if the medium has a relative permittivity, let's say 3 times greater than that of the air, then the capacitance due to that medium will be 3 times than that of the capacitance of the air. Yani capacitance in the air. Okay, is this clear? Yani you have the same dimensions of the capacitor. For example, if you have a capacitor with this cross section area, right? And there is another plate. Sorry, this is basically the top view, right? The top view mean this. These are two parallel plates, and these two parallel plates are something like this. Do you see that? These are two parallel plates, and these two parallel plates have air in between. This is plate Y, this is plate X. As I told you, that they have no dielectric between. So the capacitance of this capacitor is C with air, or C in the presence of air. You got this point? Now I have the same capacitors, but I have added some dielectric between them. The dielectric between them can be, let's say, any sort of, sorry, insulating material. Okay, this is the insulating material. Now that insulating material will create a capacitance which is basically greater than the capacitance of that capacitor which you have prepared already. So, my God, let me draw the dielectric. So somehow it is basically that medium or that dielectric which I have uh, shared with you. This is that dielectric. Okay, is it clear to everyone? This is basically that dielectric. Now, this dielectric will cause uh, the polarity, and that polarity will be used to make uh, the dipoles on this, and the dipoles will be having the strength, and those dipoles means now this capacitor is having dielectric in between. So this medium is insulating material. So that is why what will happen? This material will have actually all these capacitance. Capacitance will be suddenly increase, right? This capacitance will be increased. So this is that dielectric. What I'm talking about, that due to that dielectric, your capacitance of the capacitor will be increased by the number who, that number is the number by which that capacitance, the dielectric has the permittivity of phases. For example, as I was talking about, that this is your dielectric. So this dielectric is having relative permittivity ER. Let's say it is 1.5 times. So, you know what will happen? You just added this material in between the plates, and your capacitance has been increased 1.5 times. Is this concept clear to everyone? Is it clear to all? Yes.
Yes, sir.
That is basically, that is the presence of dielectric. Okay. Now, It means that from here I can say relative permittivity is basically the capacitance of capacitor in the presence of medium divided by capacitance of the capacitor in the presence of air only. Okay, so is this clear to everyone? Okay. Then right after that we have the topic of combinations of capacitors. So guys, there are two combinations of capacitors. One is your series combination and the second one is your parallel combination. So I will talk about this series first and then we have parallel combination. Okay. So let's say combinations of capacitors. There are two combinations of capacitor. One is the series one and the second one is your parallel one. Okay, is it clear to everyone? Series and parallel. So in series, capacitors are connected in such a way that in series one, yani here I have not given a heading to this topic, but actually it is in series combination. When do you make series combination of capacitor? When you need a reduction in the capacitance. This is very important thing. Unlike the resistors, this is important. That is why I just made a pop-up here that capacitance decreases as in as the capacitors are connected in series. Capacitance decreases as are in series. It means that when you are going to add more and more and more capacitors in series, what will happen? The equivalent capacitance will decrease. You got this point? So there are some important properties of the series capacitance formula. That is, charge on each capacitor is same. So that is why whatever is the charge accumulated here, the same charge will be shifted on the other plate, same charge will be shifted on the other plate. So that is what the capacitance of the capacitor, sorry, charge of the capacitor remains unequal. Now there is a logical reasoning behind that, that why capacitance is decreased. So as I told you, that the separation between the plates increases. So for example, this plate got positive charge, this plate got negative charge. Now positive will be shifted here, negative here, positive here, and negative here. So logically, the separation between the plate number one and plate number two, that has been increased. So this capacitor will be like this way, isn't it? So in between, there is a bunch of capacitors, and they all are making this thing possible by this way. Am I right? So it means that what is increasing? You are increasing D. D increases. Got it? Separation increases, na? So when separation increases, that means capacitance will decrease. Anyhow, we have a proof asked in our exam that Q1, Q2, Q3, they are will be equal. In series, charge is unchanged. Charge does not change, as I told you. Then C is not equal to C2 and not equal to C3. If you have different capacitors, then V1 is not equal to V3 and that is not equal to. Is this clear to everyone? Yes. So that is why you have another important thing that V1 is not equal to V2 and that is not equal to V3 and that is not equal to V3. But important thing is V1 plus V2 plus V3 that is equal to V. any sum of all the potential difference equals to V. So if you just consider this derivation includes in your syllabus, so don't ignore this derivation that is included in your syllabus. So simply speaking, in this derivation you have to start right from there, right? That V is equal to V1 plus V2 plus V3. And then you will take support of this lefter patch that V has different formulas. V is equal to Q by E. V1 has Q1 divided by C1. V2 has Q2 divided by C2. V3 has Q3 divided by C3. Got it? So if I put all these values there, Q by CE is Q1 by C1 plus Q2 by C2 plus Q3 by C3, then I simply get that charges are same. So I just took Q1, Q2, Q3 as Q. So they are cancelled out. So Q divided by C equivalent is equal to Q. That is basically taken out common. Q by C1, Q by C2, Q by C3. So Q is taken out common and cancelled out. You got 1 upon C equivalent plus equals to 1 upon C1 plus 1 upon C2 plus 1 upon C3. So actually in your series combination, the capacitance decreases. That is why your reciprocals are added, not your ordinary values. So for two capacitors, please use this formula. So when there are two capacitors in series, easy version of this formula is C equivalent is equal to C1 into C2 divided by C2 plus C2. C1 plus C2. So that is product over sum formula. What is that? Product over sum formula. Okay? When you have identical capacitors in series, then capacitance of a single capacitor. Oh, sorry. When you have a capacitance of a capacitor which is equal for others, and you have connected four capacitors in parallel, then your C equivalent is C1 divided by number of capacitors, right? C1 is capacitance of any of the capacitor. For example, if you have one capacitor of 20 microfarad and there are two capacitors in series, then the capacitance will be divided equally into two. Got this point? Yes. Clear? And is it clear to everyone? Okay. तो ये वाला क्वेश्चन आप लोगों ने देखना है. Then I will be talking about the parallel combination and charging and discharging inshallah in the next lesson. So please be aware of this all. Okay. So this is the complete topic I'm gonna send to you. But please try to make clear of this. And the best of questions are hard. Topic is very easy. I will. That is why I'm rushing towards, and I will finish it out, and we will solve the questions. Okay. Any question till this point? Okay. See you then, inshallah. Yeah, yeah.
So, guys.
Allah Hafiz. Allah Hafiz.